Hello, guys. My name is Desmond, and I welcome you to my lesson for today, where we will be looking at your physical sciences. So, ladies and gentlemen, as always, please do allow me to say it is very much important that I say it is very, very much important because, honorable members, what I'm about to say is massively, massively, massively. The J's. Massively
Yes,
important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. Meaning, by so saying, please, libandla la kaNkulunkulu, please, 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 buhle mabunda, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So I'm pretty much sure that you guys did see the question paper that was sent in the group. I'm hoping that you guys have started either with this chapter or the one that you're currently doing with Mem Ndevu. So I will just find out shortly before we go deep into today's lesson. But a very quick confirmation. Do you guys confirm that everything is clear? You can see, you can clearly hear me. For the last time, someone to quickly confirm.
yes, sir. Clear.
Okay, 100%. Someone in grade 12. Have you guys started with this chapter, or are you doing chemistry? Have you started with chemistry? Which one have you started with? Someone to just say something. Silence in court. Okay, it's fine. We will maybe get back to that question towards the end of the lesson for today. So this is what I'm going to be doing, the Jackies. I will just be taking you through this question, and I'm hoping to complete it before 8 o'clock because I've got another lesson at that time. So I'm just going to take you through this question, and then from there, on our next lesson, that's when I'm going to take you through an introduction. So it's more like I'm doing things in reverse, and you will understand at a later stage why. So it's more like I want us to apply our mind or our general understanding on this question. Then, once we have done that, as we do introduction, you will then understand everything that I'm going to be explaining in that introduction because you've got an idea of what we are trying to achieve or what we will be trying to achieve with the information in that introduction. I will see how to introduce that. So this is what I'm going to do, honorable member, very quickly to read through that given statement as we look at that diagram. And lastly, we are going to be looking at the questions. So I'm going to be explaining, I'm going to be showing you how you answer the questions. Your participation will be where you have some questions. So let's see. This is the statement. Hello, I come back. I'm just not sure of what happened there. But before I continue, is it clear, guys? Can you hear me? Zbuda, can you see? Can you hear me?
Yes, sir.
Okay. So let's see. I was about to read the statement which says a constant force, capital letter F, pulls a 50 kg block at a constant speed over a rough horizontal surface. I think we might need to do something very much important there, ladies. So they've mentioned a constant force. Constant force. What else? They've mentioned that a 50 kg block, being that one, it is being pulled by a constant speed. Constant speed. There we are having force. Okay. And now they are saying over a rough horizontal surface from A to B. They've mentioned a rough surface. Okay, let's continue. As shown in the diagram below, yes, that we can see. Now they're saying the coefficient of kinetic friction. Coefficient of kinetic friction. And this thing is actually called that. I remember I think it's called mu, something of that nature. They are saying the coefficient of friction, the coefficient of kinetic friction between the block and the surface is 0.4. So it's more like, in short, they're actually saying that mu there between the object and the rough surface is equals to 0.4. Okay. I think that's all that we are given under the statement. Maybe very quickly, honorable members, very quickly. So with regards to a constant force, it's more like whatever in Newton that is pulling that block, it's at a constant or at the same value. If maybe it is pulling it at 20 Newton, it doesn't change from point A to point B. It is being pulled by that same amount of a force. And again, with regards to the speed being constant, that means at point A, that speed, it is the same as point B. So that means there is no increase or decrease in speed, meaning the speed or the velocity does not increase. If it increases, we say there is an acceleration. If it decreases, we say it decelerates. So that means it does none of those, but it is at a constant speed. Okay, rough surface. What does rough surface mean? It simply tells us more about the frictional force. At all the times when there is a rough surface, frictional force. Smooth surface, no frictional force. I think we are aware of that. This is something that most of you guys might not fully understand, because it is the one that actually brings a confusion in the whole story. It's like, what is it like? I think it's like Archer in Sunday course. Yeah, it just ruins the Sunday course, honorable member. But don't worry, we will study that Archer to understand what it is made up of. So that's all, honorable members, that I can talk about in that given statement. The most important ways that you also need to understand. I think very quickly, very quickly, let's try to have a look at the first question and see what happens there. Maybe as we go deeper, that's when I will have much to talk about. Let's say 3.1, honorable members. They are saying draw a labeled free body diagram showing all the forces acting on that object. So this question is allocated 4 marks. I'm pretty much sure that you were made aware that if it is allocated 4 marks, it means you are possibly going to be having 4 forces acting on that object. But for now, I want us very quickly to forget about the 4 marks because it actually limits your thinking, in a sense that you always think of 4 forces that you can write. But let's try to discuss how do we notice the forces acting on any object. And this is the starting point, honorable members. This is the starting point. Where are we drawing the forces on an object? This is the object. For that reason that we are having an object at all the times, honorable members, whether the object is moving or not moving, whether it is dancing or not dancing, whether it is jumping or not jumping, at all the times, this force will always be there. And this force, you do know very well that it is that one of gravity. Someone might refer to that force as the weight. It's one and the same thing. Force of gravity, weight, one and the same thing, honorable members. Once you have identified this, you ask yourself a question. Remember, guys, I'm guiding you in terms of how you go about identifying forces acting on an object. So it's more like I'm saying, number one, think of FG. FG is always there if you've got an object. If you don't have an object, no FG. Okay, what about force number 2? Force number 2, honorable members, we talk about the normal force. How do you know if the normal force is there or not? Ask yourself this question. Is there a surface? Whether the surface it is rough or whether the surface it is smooth. Is the surface there? Yes or no? If an answer is yes, the surface is there, that means the normal force is there. If the surface it is not there, an answer to that question is a no, that means there is no normal force. I'm not sure, Sitle, if you understand what I'm saying regarding the normal force, honorable member. Does it make sense to everyone, guys?
Sir,
Hmm?
yes, it makes sense.
It does, sir.
Okay, 100%. Here comes the question. Is there a surface in this case? Yes, the surface is there. That means the normal force is there. But something very interesting with regards to the normal force. This is the normal force, but this is what I used to do. I just used to do the perpendicular thing there, just to remind me that normal force is always perpendicular to the surface. So that means if the surface is like that, wherever the object is there on that surface which is sitting in that angle, a normal force will always be perpendicular to that surface. It will form a 90-degree. Regardless of the shape of the object, it will always form a 90-degree. If the surface is like that, if the surface is horizontal, it will always form that. So your understanding of a right angled triangle, it should help you in this. So that means since the surface is horizontal, therefore we are therefore going to have normal force. You can either write it as N or you can write it as a Fn. Doesn't really matter that much, honorable members. here comes the question. I think from here, in no particular order, you can ask yourself a question to say, since there is normal force because of a surface, that surface, is it smooth or is it rough? That question will determine if there is a frictional force or not. Okay, now that we know there's a surface, that means the frictional force, possibly it could be there. What makes it to be there and what makes it not to be there? It is the type of the surface. If it's rough, it is there. If it's smooth, it's not there. But if it's there, how do we then determine the direction of the frictional force? The direction of the frictional force is always opposite to the direction in which the object is moving. Some may say opposite to the applied force, but the reason why I don't want to say opposite to the applied force is because sometimes you do not have the applied force, but still the object moves. So that is why I like saying the frictional force is in the opposite direction to the direction in which the object is moving. So it's more like I'm saying, in which direction is the object moving? Obviously, it's going to move towards the right because it is being influenced by that force. So that means the frictional force is in that direction. That is why, honorable members, I'm going to say the frictional force, it is in that direction. And then now, the other force, it is that one, honorable members, in that direction at that angle of 20 degrees. And that force, it is the one that is being called the applied force, or you can just say a force. And also, it's worth it for you to have a lengthy arrow there, so that we can also see that, okay, the longer the force, it determines the direction in which the object is moving when you compare the length of that force with the others. So that means you can have the same length as the frictional force, something of that nature. But I wasn't that much interested in giving you the 4 forces, because I know very well that you do know there are 4 forces which are allocated 4 marks. But I actually wanted us to discuss the order and how you identify those forces. The other 2 forces are the components of that one. I think we will get to that stage when the time comes, but for now, let's leave it there. So this is where, honorable members, you are actually going to score a mark for that one. I'm telling you, you will score a mark for that one, and also that one. And lastly, for your normal force. I'm not sure if that makes sense to everyone, honorable members. Did that make sense, Libandla la kaNkulunkulu?
Yes, sir. It's clear.
Okay. So now, let me remove chassis. I wish I did not have to remove all of that. Okay, maybe let me quickly redraw this thing there, because it is very, very much important, honorable members. We had that one being the frictional force. We had that one being Fg. We had that one being, let's say, N, and then there is that one being F. Yes, very, very much important, honorable members, that you have your dot, and for each line that you draw, we need that arrow to show the direction in which the force is acting. Otherwise, if you do not show that arrow, we are not sure in which direction that is moving, and you won't score a mark for that. So 3.2, I think 3.2 is something that you can easily cram, honorable members. I'm not sure whether from your textbook, whether from the notes that you're given by your teacher, but these are the three laws that we are having, and this is what Newton's first law of motion that they want you to state in words. You need to know Newton's first law, Newton's second law, and Newton's third law. You need to know all of those laws, honorable members. And you just ask yourself, which law do they want me to state? And you just state it. But most importantly, Newton is saying any object will remain stationary or moving at a constant speed unless if maybe there's a net force that acts on that object. So it's more like a Jackie. Newton is saying this object A, it will just remain stationary there, or it will just move at a constant speed of 0 meters per second. Remember, 0 is a value. So if something it is stationary, one can say it is stationary or it is moving. Moving at what velocity? 0. Or it could be moving, maybe object B, at 20 meters per second. It could be moving at that constant speed, honorable members. It will just continue until unless a non-zero resultant force acts on it. In what I've said, you can easily derive Newton's first law. So let me not go deep into that. I'm telling you guys, it took me some time to understand the interpretations of those, but I just had to cram those and make sure that when they say Newton's first, second, or third law, I just state it as it is. So now here comes a question, and they want you to calculate the magnitude of the following. Remember, the word magnitude refers to the value. So they are actually requesting you to calculate the amount. So let's see. They want you to calculate a force F. Yes, they want you to calculate force F, honorable members. Force F. So that means you need to think of any formula that can assist you in calculating the force. And as far as I remember, honorable members, there is this formula which says force net. The word net simply refers to total, or otherwise they can say resultant. And that is equals to a mother of the nation. Let me maybe try to rewrite this formula the way in which I used to write it, honorable members. Let me maybe try to do this. I used to say total forces acting on any object is equals to mother of the nation. If I have to expand this formula, I'm going to say total means you add. What are you adding? The forces. Which forces? Forces acting on that object. Where are those forces? They are the forces, honorable members. So let's see. Let's try to look at something, honorable members. Remember, we have a vertical force called a force normal. We also have a vertical force called Fg. And then we have a horizontal force called force of friction. But we have a problem because now there is another force which is at an angle of a 20 degrees. But now, if you're going to be dealing with a force which is a horizontal force, how about we yes, I'm going to say something, honorable members. How about we horizontalize? Yes. How about we horizontal? How about we horizontalize this force? Yes, that's exactly what I wanted to say. That means we will need the component of that force which is in that direction. We need to horizon. You get it? If you don't get it,
Forget about it.
forget about it. So now, the moment we are going to horizontal, yes, ladies and gentlemen, the moment you do that, that means you also need to verticalize. Ladies and gentlemen, we also need to verticalize this same force. That is what is meant by the component. So that means you verticalize it so that it can interact with that horizontal force and also those vertical forces. So now that means we can simply maybe call it Fy. Maybe let me explain something, honorable members. I will just take that and also that. So this is that force. The force, honorable members, at all the times it is hypotenuse. The force applied, it is the hypotenuse. So if we have the hypotenuse and we have the angle, that means this is the adjacent and this is the opposite. So what I'm saying is Fy, it is the opposite, and then Fx, it is the adjacent. That is why you end up having, if you want to know what is your Fx as a formula, you are probably going to say, let's see, you want to use this being the adjacent and that being the hypotenuse. Which trig ratio? Is it cos or is it sine? I think it's cos. Is it not cos that has adjacent and hypotenuse? Yes, it's cos. So now that means cos of that angle is equals to adjacent. Adjacent being Fx over that F being hypotenuse. So if you want to know what that is, obviously you cross multiply. So that means actually Fx is equals to that F cos of whatever the angle that you are having there. Let me just say angle theta, just to generalize. So that means F horizontal there, it is actually equals to that force which is at an angle cos of that angle. Obviously, this is opposite. You still do this. For opposite, obviously, if you want to know that opposite in relation to that force, that means it is sine. Yes, it is sine of an angle is equals to opposite over hypotenuse. You still cross multiply, so that means Fy it's equals to, what is that? I think that is, yes, the hypotenuse force and then sine of. That is why, honorable members, we end up saying that one of the vertical, it is actually that force, a sine of whatever the angle that we are dealing with. So that is how very quickly you horizontalize and how you verticalize. lies. Why do you do that, honorable member? It's because you have a problem. That is the problemo. The problemo is you are having a force which is at an angle, and you can't mix it with a force which is horizontal, vertical, and vertical. Try to also horizontalize it. Try to horizon, ladies and gentlemen. But I think you get my point, honorable members. It's difficult to say horizontalize, but to say verticalize. But I'm sure, honorable members, you will never forget that when you have a force at an angle, you might need to horizontalize it and verticalize it so that it can interact with those on the formula. Sinesetulingalizo. Are you sure? Uvulile amadlebe, honorable members. Uyayizwa le ndaba ukuthi ihamba kanjani. Ngoba masuzizisa le ndaba le, I'm telling you, to calculate is very easy. Easy. Sihle phakathi. Are you sure? Uvulile mandlebe. I see Chumi the Chumis is on the line. Ngwana Maleti, wa ka ro lebeletse scheme sa me ko o re ntho bagale a ko tshepe wena, honorable member, ungathi ubuke scheme sami lapho. Let's see who's on the line. No, Hamisa, I know how to know if Hamisa is on. Okay, there is Butle Mabunda. But wait, before I continue, guys, we are clear on that one name.
Yes, sir.
Yes, sir.
Okay. 100%. So that means we already know that that one, it is force x, which is equals to that force cos of an angle. We do know very well that that one, it is actually that force sine of an angle. So it's more like we have free body diagram just to show the original forces acting on the object. But for the purpose of calculations, you need to understand that one. So when I take you through the notes, I'm definitely going to train you on how you draw free body diagram on different objects or on objects in different situations. Because once you've mastered that, I'm telling you, honorable members, it is going to be very, very easy. Remember, I said F total, it's equals to mother of the nation. So that means I need to consider all the forces acting on that object, all of them, because that's when we talk about what is it? Total force. All of them, honorable members. So that means maybe let's start with all the horizontal forces. We are maybe going to add them with the vertical forces. Those forces are equals to mother of the nation. But what we know about mother of the nation is that M is M and then A is that acceleration. Maybe let's expand it. We know most acceleration is what? Is it not V final minus V initial, the whole of that over time? Remember, guys, I'm just expanding all of that so that you understand where everything comes from. Not that much interested in the calculation itself, but just to break down all of that. Let's see. How many horizontal forces do we have when you look at that? We obviously have two. We obviously have two forces. One can say you can assume the right to be positive, the left to be negative. So it's more like forces in that direction are positive, in that direction negative. Same for up and down. So now for the horizontal forces, that's where you can say you are having that positive Fx. Obviously, friction is always a negative force. Always. Friction, it's a negative force. Maybe you can say force of friction. So I'm done with the horizontal forces. Obviously, you plus because it is the total forces. Now you look at the vertical forces. So the vertical forces, you can still be assuming, what is it? Up to be positive, down to be negative. So we have the force normal, which is going up. We also have which one? The F Y also going up. And then we have FG going down. That is why I'm having a minus there. And all of that is equals to a mother of the nation. So before we even get to that, let me actually show you guys something. So again, one can say, I'm just going to add all those forces. So I'm having the force in that direction, plus I still have the frictional force, plus I still have the normal force, plus I still have that one of the component, plus I still have a FG. All of this is equals to mother of the nation. The reason why you end up having some other forces cancelling out is because you ask yourself this question: is the object moving up and down? Yes or no? Is the object moving up and down?
No.
If the answer is no, that means all the upward forces are balancing with the downwards forces. So that means these two forces going up, they cancel each other out with all the forces going down. In this case, we only have one force going down. So that is why this force, and that force cancel each other out. Here comes a question: is the object moving in the sideways direction, either left or right? Yes or no? Is the object moving left or right? Is the object moving horizontally? Yes or no?
It's moving horizontal.
Yes, that is why these two forces are the only two forces which do not cancel each other out. Why? Because there is motion. So that is why when you formulate, you end up having not these forces, because the object is not moving up and down. So what I'm saying, honorable members, is that this force, it ends up cancelling with those, and you end up having these two forces, because the object is moving in the horizontal direction and not vertically. Just, I'm not sure if I'm confusing you guys on this one, because with you not understanding that, it's going to be difficult, honorable members. Does it make sense what I've explained there? Mpandla kaNkulunkulu?
Yes, sir.
Okay. So now I'm just going to remove all of this, and then straight away we answer the questions. But remember, guys, just in case if you are uncertain about what I've explained, I am still going to do a lesson where I take you through all of that, where we don't do any calculations. We just focus on this type of content in different situations that you will come across. So in this case, where they say, what is the calculation? They said calculate force F. So I know that the formula says force net is equals to a mother of the nation. So you expand that A if you've got acceleration or deceleration. If there's acceleration or deceleration, that's when you expand it. But where they say this thing, it moves at a constant velocity, it's more like is your v final minus v initial divided by whatever time. So if they say constant, they mean if the velocity is 2, if the final velocity is 2, also the initial velocity is 2, is the same velocity throughout. So already mathematically we know that the moment you have 0 and you divide by whatever, it ends up being 0. So that means we actually have 0 inside there, and that multiplied by 0, it ends up 0. So that is why at all the times when you are having a constant v, mother of the nation, it's equals to 0. That's how it comes about. So let's see. I've just explained that because the object is not moving vertically up and down, that means we only focus on the horizontal forces. What are those? We know that we have a Fx. Maybe let's plus it with frictional force. We know it's equals to m. Acceleration, no acceleration. We are having 0 there. I've just explained. So we do know this one most. We know that Fx is actually the force that we are looking for. What else? Cos of an angle. We know very well that a frictional force is always a negative force. I want to make you guys aware of something very much important. Frictional force has a formula. Frictional force, the formula for calculating frictional force is equals to mu, that mu k times normal force. I'm not sure if you guys were aware of that. And guess what? Normal force, we do have a formula for that. Normal force, it's actually the same as force of gravity. These two are equal. And guess what? We know that the force of gravity is actually equals to ma. No, not ma, but mg. So maybe let's work it in reverse. If we know that n, it's actually equals to fg is equals to, so that means actually this force of friction is actually equals to mu k mg. So that means this is the formula for frictional force. M refers to the mass of an object, of which in that case we know it is 50. G, it doesn't change. We know it is always 9.8. This one, it depends on the material. If maybe you are having an object moving on a gravel road, maybe the mu might be whatever a value, honorable members. Obviously, if maybe you are sliding on a surface which is ice, the mu is going to be different. I'm just giving an example. It's going to be different. if maybe you are sliding, let's say, on a slice of bread, honorable members, I'm not sure if you guys do that, but if you are sliding there, the mu is going to be different. So this one is dependent on the type of material where the car is moving. For example, if a car is moving on a skontiri, a tar road, it's going to move smoothly. But if it's moving on a gravel road, the friction is high there because of the type of material which is determined. I think that makes sense, honorable members. Maybe let's try to expand that formula and see how far we can go with that. So I've just said frictional force, it has a formula which is mu mg. That is equals, obviously this is 0, so let's not waste time and put 0 there. Jesus, I'm not sure if I'm losing you guys on that one. Can someone say something, honorable members? Are you sure? Hmm. Guys, are you sure that I'm not losing you on that one? I don't know why I'm having this feeling that.
Me, I'm still fine. I don't know about the others.
Sir, I have a question.
Yes.
Why are we adding friction? Isn't friction supposed to be going the other direction? So it's not supposed to be minus.
She's asking a very good question there. But where here are you asking about that? Maybe let's say this is 1, 2, 3. Where are you asking, honorable member? Let's say this
one.
The second, this one. Ne? So what is the question again? Can you maybe repeat that question?
I'm asking if since friction is the opposing force, aren't we supposed to be subtracting it instead of adding it?
A very good question, and this is how I answered this question, honorable member. What does this mean? I'm not sure if it's Tola. Tola, what does net mean?
The resultant or the total?
Yes, total means you add. I'm not sure if I've answered your question, honorable member. That is why you have that force, you plus it with another force. So it's more like this formula is saying plus all the forces on this object. You plus them all. And then after you've plussed them all, I'm sure you noticed how the vertical forces cancelled themselves out. And then you just remain with the horizontal forces. I'm not sure if I lost you but does it make sense what I've explained? So here I was just saying frictional force, it's actually mu mg, and this mg is what we know that mg is actually the force normal. It's what the force normal. This chapter is a bit complicated, honorable members. Trust me on that one. But once you understand the basics, you will actually have an idea of how to interpret those. So for today, I just want to take you through this question so that when we do an intro, you will have a background of what we are trying to achieve and why you need to understand everything. But did I answer the honorable member on that one where she was saying, why are we adding there? We added because the formula says Fnet or F total or F resultant. After this stage, that's when you can nicely say you are having a plus that because it's in that direction, and then this one it's a minus. This is where that minus is coming. So it's more like now I've written the same thing. That is F frictional force as a minus there. But I just explained that the frictional force has a formula which is mu normal force. Yes. Does it make sense now, honorable member?
Yes, sir.
Okay. So now let's try maybe to continue. Let's see. We do know that we have F, which is what we're looking for. Cos of obviously an angle is 20 degrees minus. Do we know what mu is? I'm not sure if we know what mu is, but I think we do know. It's 0.4. So here now we are having a problem. This question is allocated 6 marks, honorable members. It won't just be an easy question. So isn't there something that we know regarding N, honorable members? I'm just not sure. Do you guys not remember that we said actually the vertical forces, they are equal. They cancel each other out. So it's more like all the upward forces are equals to the downward forces. I'm not sure if you remember this or if you understand this part. Do you guys understand this part? That because this thing is not moving up and down, so that means the forces are balanced, meaning the upward forces are equals to the downward forces. Does it make sense, honorable members, what I'm explaining there?
Yes, sir.
Okay, 100%. 100%. So now, let's see. Let's try to formulate. How many upward forces are we having? We have the normal force. What else do we have? We have that one. I'm not sure if you remember this one of F, a sine of an angle. I'm not sure if you remember. Which other force? We also have the force of gravity. We know most the force of gravity is mg. Do you guys remember? We just discussed. I think you do remember. Let's maybe try to make n subject of the formula. So that means n is going to be equals, will it not be mg minus f sine of an angle? So it's more like I'm saying we are actually going to have mg there minusing f sine of that. Obviously, an angle is only one, which is 20. Did I not lose you guys on that one? Maybe let me not remove and ask if I didn't lose you on. Guys, did I not lose you on that one?
No, sir.
No, sir.
Okay, 100%. Remember, guys, it might not be easy for you to do all that I've done or not know how did I know what I was supposed to do. That's why I'm saying on our next lesson, everything is going to make sense. We won't be solving any questions, but just to look at scenarios in different cases. So obviously, this is the honorable member that we are looking. So that means we have got F that we are looking for. We have cos of 20 degrees there minus 0.4 there. We know what M is most. We know M, it is 50 that we need to multiply by 9.8. This is the honorable member that we are looking for. And then we have 20 there. This is equals to 0. I will just give you the final answer because you just need to apply your mathematical knowledge to work out that. Obviously, you're going to say da ba da, da ba da, and then somehow you work it out until you get your final answer. On my calculations, it's 18 point, maybe let's say 16 Newton. Yes, you will work it out until you get that. If you can't find that answer, just know your problems are not in physics, but your problems are in mathematics. Did you guys get that one in terms of how we approach it? Not the calculation part, because that you're going to do, but how we actually look for that F. Did you guys get that one?
So can I ask, which one is
Yebo.
which one is F sine 20? Because I can see that the first applied there is cos 20. Then the normal force is mg. Then which one is F sine 20?
Mm, Justice, I think I will still need to understand but I understand where I lost you because all of that it was actually included in my previous explanation. But do not worry that much. Just make sure not to miss my um, next lesson. So wait, what was the question again? Can you ask the question for the last time? I want to see if I can summarize in answering your question. What did you say there?
Asking which one is F sin 20 because I understand that mg is for normal force and
Mm-hmm.
the force applied is F cos 20. Now I'm confused with this one, F sin 20.
Okay, now I see. So normal force, what we know about normal force is that normal force is normal force, yes. But uh, how am I going to explain this one? Let me again explain where that comes from, because I understand that's where the confusion is. I'm not sure if you remember, we're saying the upward forces balance with the downward forces because that object is not moving up and down. I'm not sure if you remember this one, honorable member. Do you remember this one?
Yes, I remember that one.
Yeah, so from that understanding that we know that normal force is obviously that one in the upward direction, and we also have that one of F sine 20 also in the upward direction. It's equals to the downward force, which is mg. You remember this one, most honorable member?
Yes, I remember that one.
Yeah, so what we did was actually to try and make n, the normal force, the subject of the formula from all of this, just so that we can take it and substitute it there, so that we have it in a form of f. So it's more like your n, it's equals to that mg there minus the whole, you take it to the other side. So it's minus f sine of 20. So that means actually we made n the subject of the formula. Then we take it as it is and then we substitute it there. Because this one we know, this one we know, we are looking for this, that one we know.
Yes, is it possible to achieve the same answer even if we use one of these two forces, those two gravitational force, a normal force,
Mm-hmm.
because it's mg and it's equal to the other one, so we just not use the other one.
So you're saying if we don't use this one,
Exclude one of them.
oh no, you can't exclude. It's impossible to exclude. The moment you exclude, it's more like those forces are not balanced. Just as I'm not sure of how to respond to this one, but you can't exclude. You can't exclude. That is because Fnet, remember, we focus on all the forces. So it's a matter of how many upward forces are we having. We have two of them, so they balance with this one, even though it's one force. So this force of mg, it can be powerful enough to balance these two forces going upwards. So that is why we say all of the upward forces, they balance with all of the downward forces. So we have two forces going up, they must be equals to one force going down. The moment you exclude this one, then that means we also have a vertical movement. It's either the object is now moving upward or downward. I'm not sure if you get me on that one, honorable member. So you can't
Yes,
exclude any force.
I understand now, sir.
Yes, yes. So that is why I think. Thanks very much for saying. The reason why, honorable members, I call this mother of the nation is because you cannot abandon your child as the mother. So that means honorable member wanted to abandon ingani. You won't forget most when I say this, honorable member.
Yes, I don't know if I'm right. Sir. Sometimes I used to see them using one force. Maybe they will use the one that's an F sin 20. Then it will be mg sin 20, not the other one. I don't know if the cases are
Yes,
different.
so the cases will at all times differ. But for now, just remember what we discussed for this one. Then on our next lesson, make sure not to miss it. That's where we are therefore going to go deep into all of that. Nay.
Okay, thanks. Sir.
And who are speaking? I think I'm hearing that voice for the first time. Who are speaking there?
Moses.
Oh, Moses. Okay, so let's see, honorable members. Okay, so obviously 3.4. I'm actually rushing because I noticed I was supposed to have started another lesson. Yes, I think I was on 1%. Honorable members, let me quickly connect, and then from there, just before I run out of battery, let me connect with my external. Honorable members, before I forget, tomorrow I'm going to tell you what time. After you attend your whatever geography lesson or life sciences, we are also going to do that revision on YouTube. Make sure not to miss it. I will communicate via text in the group. So 3.4, they want you to calculate the normal force. I think it's going to be easy. This one is allocated 2 marks. I think it's going to be easy to calculate the normal force because you obviously know what the formula is for calculating the normal force. You can still derive it from what we have done to say we have normal force going up with F, a sine of an angle which balances with mg. You can easily find that because I think we have everything, honorable members. This one we know we calculated it. This is the angle, and that is m, that is g. You can take all of this to the other side, and then you calculate the normal force. Let me leave it there. We might revisit this question, but you can try it and then submit. You know how to submit most. And then now, this one they are saying the frictional force. The frictional force, honorable members, again, you know what frictional force is. I gave you the formula most. I think I said it's mu normal. Yes. Or it is mu normal. We know that normal is mg. So obviously, on this question, you calculated normal. Why not substitute it there? You know what the mu is. That's how you calculate a frictional force. Again, you can also work out that one and then send me the information. Then I'll verify for you. And then there's the last question, which says, for that same scenario, in this case, this force is no longer like that, but it is now in that direction. What is the difference? The difference is that one, it was pulling, and then this one, it is pushing. Between these two, this is the hard worker. This one of the pulling, it is a smart worker. So this one, they're going to work harder. What makes them to work harder? It is because of the high frictional force. So it's more like now when they push in that direction, ask yourself a question: does the normal force increase or decrease? And when that happens, then what happens to the frictional force? That's what you need to ask yourself, honorable members. But if you want to know if the normal force increase or decrease, think of it this way. You know normal force is equals to what? Mg. So it's more like you're saying, is this thing increasing or decreasing when this person is actually pushing in that direction? If mg is increasing, that means the normal force increasing. And when the normal force increases, what happens to the frictional force? We know that this is the formula for the frictional force. So that means if N is increasing, that means here you're going to have an increased value, which will increase the frictional force. So with what I've said, that's how you can possibly answer that question. Ladies and gentlemen, I need to quickly run away to my next lesson. I notice I've actually lost the time. So honorable members, I've already signed out, but the code for today's lesson, comment with whatever chapter that you have started with at your school. That is going to be the lesson. No, the code for today's lesson. Did you guys get that? I think
Yes.
you did. Yes. Okay. Thanks very much, Hamisa, for confirming that. So, guys, tomorrow, what time? I will see just after your lesson. Then there's going to be that revision. Just make sure not to miss it. Okay. Now I'm out.